say there are three types of truths. The one related to the one recorded through the senses, right? You see something, you think it's true. You feel something, I mean, not you feel, but you touch something, you know it's concrete or something. It's true, right? It's a wall, yeah, it's whatever. And you smell something, you know. But then there is a truth based on beliefs. I believe the electron exists. I believe in this theory. People think they can prove things, but has anybody seen an electron? No. But you believe it exists, right? That's beliefs, right? And then there is the absolute truth that nobody can guarantee they know. Because if you look at any theory, there's always somebody who says, well, the theory is good, but it's incomplete because in these situations, it does not work. For example, as the speed of an object increases near the speed of light, mechanical classic doesn't work, right? I mean, the mass is a constant. It's not a constant anymore, right? Time is not a constant anymore. So there are a lot of things that, you know, you believe, but it does. We don't know. We don't have access to the absolute truth. So we live with what we have, and we advance. We are engineers in training, so we advance version 1, version 2, version 3, and hopefully someday we'll get closer and closer to the absolute truth. That's all that matters, right? I mean, that's the trip, the adventure in the trip, right? So we have Nicholas Carry On. We have Christian Rice that is here. He thinks I haven't taken attendance, but I haven't yet. Nicholas Dylan Solis. So Nicholas 1 and Nicholas 2, that would do, right? And of course, yes, Nicholas, how are you? Yeah, well, you're not, your microphone has disappeared. Does your microphone work, Nicholas? Oh, okay. Well, that's because of the bandwidth, most likely, or your computer is doing something in the background. That happens a lot. You know, like when you have the antivirus working, definitely the microphone goes down. It goes down, and it doesn't stop, but it breaks. You know, the voice would break in between. Yeah, that happens. And sometimes it's a matter of bandwidth, but usually the voice is not much of an amount of data to be transmitted, right? But it is true that if the signal is bad, especially you guys most likely use wireless connections, not cable connections, that happens a lot. But I've seen it with somebody who had a very good internet speed, but the antivirus was working in the background, and it was probably delaying the CPU from registering the voice and transmitting it. So that happens. Because theoretically, anything else should stop working. Even the antivirus, theoretically, when you're busy, it should pause or should whatever, right? But you never know. One question, which problems did I sign to be submitted for this week? I could go to the recording and check it out, but doesn't anybody remember the problems? (26) 1 and 3. Beautiful, David. Thank you so very much. Obviously, I posted it, homework 3, and I'm giving you until Sunday, just in case, right? In case you want to discuss something today or whatever. I don't like to delay things too much because people tend to procrastinate, and that means you're going to have a weekend waiting until Sunday night to do some work. So the sooner you do it, the better off you are. But what are you going to do? So we hope that Nicholas will work out his microphone problem, because I like to hear people's voices. But then again, that's up to you. Sometimes, you know, I've seen with some students, they have a lot of noise in the background. As long as it does, edition 4, I think it's 4, right? But I think it's the same. Sorry, for both. For those problems, it happens to be the same for both, right? I think it's the same for both. So just in case, most likely. That's why I gave only those numbers, right? I didn't give the 2 versions. What page? Come on, man, you go to the end of the chapter, right, to find it, right? Of course, 26 is from chapter 1, and 1 and 3 are from chapter 2. So that's obviously should have been understood, right? At which page? You just scroll until you get to the end of the chapters, you know, then you find the problems. But I like that, you know. I like that. I hear it every semester, almost every week. It's like whenever I say problem 3, what page? What do you mean, what page? Somewhere at the end of the chapter. And then which line, right? Who knows, right? And who knows what. Hello, Christian. How are you?
Fine. Yeah, I wanted to say that when I was looking at chapter.
Oh my, this guy is complete in his information. Oh, you're so nice. Thank you.
Professor. No, I was confused because when I was
Is Christian
looking
talking? Because I can't hear you, unless my speakers are bad. I don't know.
Can you hear me
Can
now?
anybody say something so I find out if my speakers are bad, or at least it's not appropriate? Say something, Christian. Ooh, wow! I hear you loud and clear. That's very nice.
Yeah.
That's good. Do you have anything to add? Do you have any comment? Do you have any problems? Do you have any?
When you look into the book for the third edition, when you said chapter
Yes.
1, so when you put these numbers, those are the problems, right?
Yes, of course.
Of chapter 1, are we in, or chapter 2?
No, 26 is from chapter 1,
Okay.
and 1 and 3 are from chapter 2.
All
Because I just want to give that problem, it gives you something more complex to work on, right? And chapter 2, because we started already with chapter 2, so. Right?
Yeah.
And Christian, do you know that you have a quiz today?
Yes.
But it's, it should be easy, so it's no big deal. It should be easy. Once you see it, you'll know. Lucky you, right? Do you have any questions, guys, before I move on? Right? I mean, we'll move on with the lecturing, that is. Usually I give about 10-15 seconds. If there is nothing, then I just move on with the lecture. Could be worse, could be worse. No, that's at the end. At the end of the session. The quiz will be taken at the end of the session. Definitely. Oh, yes. Okay, so let's start with the lecture. So in this case, I just want to remind you that we looked at the combination of arrays, and we said the first step was to create bigger arrays from smaller ones, and we call that combination, concatenation, appending, you name it, right? And we had seen two ways of combining arrays. We can combine them horizontally using a comma, and we can combine them vertically using a semicolon. That's one under the other one. We have said that for a horizontal combination, they have to have the same number of rows. Same number of columns is not relevant, right? That's not needed, but same number of rows, mandatory. And for a vertical combination, they have to have the same number of columns. That's a must. We have also seen the idea of a transpose of an array. And I have said at that time that a transpose is just merely the equivalent of the first array, except every row becomes a column, right? The first row becomes the first column, second row becomes the second column, and so on. And we will see in the near future why that is an important operation. Of course, you will not see why it is important in the case of matrix operations, right? That we will not deal with, but it is a very important operation on matrices when we deal with matrix operations. But in our case, we will see it in applications and why that transpose would be helpful. So today we're going to see the opposite version, which is instead of creating bigger arrays, is how to extract a piece of an array and form a smaller one, a subset of, right? A subset of a big array. It's like saying, imagine if I have 10,000 employees and I want to pull out from that array only let's say the employees who are older than 50 years old, or only the employees who work on fabrication and so forth, right? So I want to pull out and create another array just for those people, right? For whatever reason. So we're going to see all the operations that are involved in extracting elements from an array to form another array, a smaller one, right? For example, when we start with vectors, right? Here, before we talk about how to extract, we can remind you that when I use the expression x of m, right? it means give me the nth element of that vector. So x of 2, give me the second element. So starting from the beginning, give me the second one. X of 5, give me the fifth one, and so on. So here you're pointing to a single element in that vector. So here we're talking about vectors, right? Single rows or single columns. However, x colon says give me all the elements of the vector. But here we're going to be seeing something that is special when we deal with the two-dimensional arrays. But in the meantime, when we are sticking just to vectors, it just means like if you type x, right? The format of the output may be a little bit special, right? Whether it's if it's a row, whether it stays as a row vector, right? But x colon, we're going to practice, and you're going to tell me the answer to that question. Whether a row vector will be a row vector, and whether a column vector will appear as a column vector. Because x, then enter, it will give you x just the way it is. If it's a row vector, it's a row vector. And if it's a column vector, it will appear as a column vector. But x colon is a little special, right? So we're gonna ask you to check it out, and you tell me what the answer should be. When you work with x2 colon 5, and again, we're still working with vectors. It just means here, 2 colon 5, you know very well that when you use the colon, it's a pattern of numbers. And the increment is by default 1, because I didn't put it there, so that means it's every 1, right? 2, 3, 4, 5, and so on, right? That's what it means. 2, 3, 4, 5 in this case, right? So that means give me the second, the third, the fourth, and the fifth element of the array x. And you make a new array. And that new array will have only 4 elements, which is the second and the third and the fourth and the fifth element of x. And now I have a new array with 4 elements, right? So if you want to extract, if you do not have a pattern, for example, I want the element, the second element, the fifth, the 15th element. You know, there is no pattern between the numbers, right? How would you do it? Theoretically, you should be able to have an idea, right, based on all that you know from before. How would you ask specifically for a third, the fifth, and the 15th? Or any number, as long as we don't think there is a pattern between the numbers. What is your suggestion? So if I want to extract the third, the fifth, and let's say the 20th, right? Third, fifth, and the 20th element of x, how would you write it? X what? Three, 5, 20. How would I write it? It has to be the same as this one, x and something, a bunch of numbers, right? Obviously, we didn't use, I did not show you like when you have multiple numbers, but try to tell me, how do we deal with a bunch of numbers? You know, a bunch of numbers means an array, right? So start with x parentheses and then tell me what the inside should look like. How do you exhibit a bunch of numbers? What does this remind you of? A bunch of numbers. I put something on the chat that should give you an idea. Come on, guys, give me something to work. I don't care if it's wrong, you know. I don't care about that. I only care about you teaching yourselves, right? Coming up with something that could work. Except we don't need, yes! So I was going to say we don't need the semicolon, we need the commas, right? Because it's just a vector, right? Oh, you're so polite, Adrian. No problem, Alexandro. So that's the idea. I mean, here, the only examples I gave are like when it's a pattern, I know that's a good guess, you know, but that's what teaching yourself is, right? You try something. If MATLAB answers with something that you like, that's good. If it doesn't, then you know, okay, so let's tweak it and make it work, right? That's how you teach yourselves. This is not a field where you wait for somebody to tell you what to do, right? When it comes to programming, you can only learn by doing. I can assure you that. That's the only way to learn, right? You can check other people's programs, you have an idea of what they do, but until you try things or until you do things your way, you will never learn enough to be confident. So just learn to do it, right? Instead of waiting to ask a question. It's to ask a question only when you try, and you just can't find the solution. Then you have to ask at that time. You cannot stop yourself, right? Welcome back. I'm back, Alexandro. Yep, I'll be back. That's a threat from the Terminator. So, okay, so that means now you're getting to that point where you're going to have to teach yourselves. Just like I said with the X colon, right? You try that with a row vector, you try that with a column vector, and maybe there's going to be a little difference, maybe, instead of just X enter, right? So that means that colon may be useful, right? But useful only, let's say, in some application. You say, well, in this application, I'm not going to just use X, I'm going to use X with a colon, right? So that's what you're trying to learn, not only knowing what it leads to, but how to benefit from the result as it is presented. But we're going to do that soon, right? Just remind me to ask you to do it. Now, if you deal with a two-dimensional array, that means multiple rows and multiple columns, right? So now we need two numbers. We need two numbers, not just M, but M and N. The first number represents a row, or the row number, and the second number represents the number. And so the intersection between a specific row and a specific column, that's the element you are interested in. So that means I want the grade from, let's say, Christian, right, from quiz 3. So the row, Christian, and the column, quiz 3, that's what I want. That means, of course, the grade for that quiz for Christian, right? So the idea here is that when you have two numbers, that's what it means, right? Give me the element from the array that intersects at row M and column N. Now, here you will have an idea of what the first one could be. Because here, when I say X colon, so even though it says give me all the elements of X, but the way it's going to present them is going to be special. That means instead of just showing the array, like when you say X enter, it will just show you the array the way you presented it, right? Whatever X is. But when you put the column here, it's gonna display the first column, then takes the second column and put it on underneath, and then takes the third column and puts it underneath. And so at the end, it will appear as a single column, like it will appear in memory, right? Because in memory, you don't have multiple rows and multiple columns, right? You just have a single column of numbers, of stored information. And so here now you can see, if, of course, we decide to store column-wise, what we say column-wise, that means we store the first column first, then the second column, then the third column. If it is done that, of course, you don't do it, right? It's the hardware that is programmed and designed by the engineers that will make that happen. So in memory, they may appear this way. The first column, then the second column later, then the third column later. It will appear to you in memory when you see it. It's like a single column. So that's what X colon would be. However, when you deal with X colon 3, so now you see that the first number is always about the row. The second number is the column, right? When you use column by itself, it means all rows, every row. That's what the column means. Here, it's only a single column. That means every row and every column, but they will appear one column at a time, right? But here it means every row, but only the third column. That's it. So in English, another word of describing this expression, you say the entire third column. Because when you say third column and every row, that means the entire third column. So in your mind, that's what you see. You see the entire third column. Here, again, it's every row, but second to third, right? Even though here it means the same thing as second and third, right? But because we put a default increment, which is 1, and 2 plus 1 is 3, that's it. That means the second and the third, but really you should say from the second to the third, right? Because it's like a pattern, right? But of course, in this case, it means the same thing. It's only the second and third. But we will see later that things may not be that simple if you don't make a difference. So again, it will give you the second and the third column, but it's the entire second and third. The entire, why? Because it's every row. Here, I'm a little bit more specific. It means the second to the third row and the first to the third column. So here it's important to say to the third. Why? Because 1 colon 3, it means 1, 2, and 3, right? Because the default increment is 1, so 1 plus 1 is 2, 2 plus 1 is 3. So it is from the second to the third and from the first to the third column. So you take the intersection of all these terms, and that's what your new array would look like. However, just like we learned about the brackets a few minutes ago, here it says from the second to the third, but only the first and the third. You see here between bracket, that means these are the only two numbers that I'm interested in. The first and the third only, nothing else. But here it says from the second to the third. Of course, it means the second and the third, right, in this case. And so again, it's the intersection between the second and the third row and the first and the third column. And you take those elements and you create an array. And so the last two are related to trying to help the programmers decide that if you have a spreadsheet or if you have an array and the number of rows and number of columns is extensive, right? And you may not know, right? You may not know how many students I have in a class, right? But I want to deal with the last student in the list. I don't care. Yes, I could find how many rows, how many columns and everything. But in this case, I specifically want to deal with the last student. Or in this case, the quiz, because end is as a column, right? So the last column. Here is the last row. Here is the last column. That's all I care about. So in this case, when I want to deal with the last row, and here you see here the column, it says all, right? All columns, right? Every column. That's what a column means. That means if it is the last row and all columns, that means the entire last row. And so what would be the English equivalent of this one? I need for you to tell me the way I said it with this one. What would you say about this one? Come on, guys, suggest something. I said this is the entire last row. And this would be, come on, guys, I'm huffing and puffing here. Yes, yes, Alexandro. Yes, very good, very good, very good. I'm not saying very good really to the correct answers, right? I'm really saying very good. That means you're participating, and that's very very helpful to me, right? That you are interacting with me, you know. So in this case, when we look at examples, let's say this is a two-dimensional array. 1, 2, 3, 4, 5, 6, and so on. That's 4 rows and 3 columns, right? So in this case, it says every row from the second to the third. Every row, but from the second to the third. Every row, that means the entire second and third. And that's what you see here. The entire second and third column. Of course, theoretically, I should have said the entire second to the third column. But it means the same thing here, right? Here it says the last row, every column. That means the entire last row. Well, the entire last row is 10, 11, 12. Here's the entire last column, which is 3, 6, 9, 12, right? And here, it means specifically every row, but the third column only. And that's what it is, right? Every row, that means the entire third. Look at what X column looks like. If I say X, this is what it looks like, 4 rows and 3 columns. But if you look at X colon, it says take the first column, 1, 4, 7, 10. Then take the second column and put it underneath. And then take the third column and put it underneath. So now it appears like as if like it's stored in memory, where this is stored first, then this is second, this is third, it is fourth, and so on, right? So it's important to know how it would be stored, right? Of course, you with your pointing X, M, comma, N, you can do whatever you want, right? But how it is stored in memory, that's for the people who program the hardware and the way it deals with data. That let's say if it's stored column-wise, this is exactly how it would be stored in memory. One column, then the next column, then the next column, and so on, all the way until the end of the data. So just remember, X by itself, it's still the array the way it is, like whatever number of rows and columns, but X colon, it's just one single column regardless. So what I want you to do under MATLAB now, and do it on your own, right? And take two examples. One example is create a row vector like this and use X colon, and create a column vector like this one and use X colon, and tell me what you get at the end. Go ahead, be my guest. What I said is create the row vector, let's say 3 elements, and use X colon, and then later create a column vector and use X colon, and tell me what the results would look like or what observations you have. Anybody with comments, suggestions, observation on what happened? Did you all have to take time to start MATLAB? I'm sure, right? That's theoretically something you should have on as soon as the lecture starts. Okay, go ahead, Alexandro, tell me. Or tell us, not don't tell me, don't tell the class. What did you observe?
Oh, I was just saying I got it, as in, like, I have an example, and I just ran the program. That's it. Because, I mean...
Yeah, what did you observe when you ran it? Or, can you share your screen and let us see what you did?
Sure.
Go ahead. You just go to that box with the curved arrow, and you just say share, share application.
There you go. Do you guys see it?
And we see it? Yes.
There you go. So this
except,
is
except that I wanted you to share with us, create, let's say, y equal, but a row vector.
What, like just a row? Oh,
in fact, no,
a row.
Yeah, don't, you know, y equal, but don't create it directly. Let's try to create it from, say, the first row. How would we do it? Ask your friends. Yeah, but I don't want you to create it by hand. I want you to create it the way we learned before. Yeah, how do I extract the first row? But say y equal so that we give it a name, right?
Oh, okay.
Y equal. Okay, then what do we put? I want the entire first row.
There is, I forgot if it was a colon or a semicolon, but you could put it at the beginning and it nullifies it. So you can only pick a column or a row.
Well, ask your friends, man.
Yeah, which one is it? Is it a colon or a semicolon? Oh, wait, hold on. I gotta. Let me see the chat. Okay, it's a semicolon. Thank you.
Don't think I use semicolon anywhere. The entire first row. So obviously the first number should be 1. It's the first row, right? Yeah. And that represents the row. Then we use a comma, not a semicolon, but a comma. Yes, yes, Adrian, that's right. And then what? The entire first row. What is the symbol that represents entire? Means every column.
Oh, the colon. No, wait.
Yes. Yes. The colon represents every. And since it's the second one, that means it's about the column, right?
Yeah.
So enter. Yes, Shafiq, that is correct. That's it. Now you got the first row, right?
Yeah.
Now, type y colon.
All right.
Yep, every number, exactly. No. Remember, when you address an array, you have to have parentheses, remember?
So just colon by itself?
Yes.
All right.
You see? Now what do you observe?
Oh, it still calls back the first row, but...
Well, y, forget about x. We created y, which happens to be a row vector, and now it became a column vector. But what I was going to say is that instead of thinking of it like, oh, it became a transpose. No, the idea is that you take the first column, which happens to be only 0, right? Then it takes the second column, which is 1, because there is only one row, right? So 1, and he puts it underneath. Then it goes to the third column and puts it underneath, and then goes to the fourth column and puts it underneath. When it was a row vector, it's easy, right, to think of it as if you did the transpose, right? But of course, that I don't like to use the word transpose, because if you had a column vector, it remains a column. It's always shown as a column, right? One column at a time and underneath each other. That's why with the two-dimensional one, it was more clearer. It takes the first column, then takes the second column and puts it underneath, takes the third column, puts it underneath. That's what X colon means, right? It means present to me the data as if it's stored in memory, one at a time. It's only one at a time. You don't have rows and columns in memory, right? You have one column of numbers. That's it. That is RAM, you know, they're going to say memory, the RAM, you know. If it's programmed to be stored column-wise, that's the way it's going to be, right? Ask them if they have any questions, or they want you to show them another situation that they want to learn from, or what. Ask them.
Do you guys understand what's going on here?
Of course, you don't have to say, yes, I do. If you have any suggestion, if you have any question, then you should say something. Otherwise, we'll expect, it would be implicit that you got it, and you don't need to see anything else to learn more. So it says, yup. Okie dokie. I will call on you sometime soon, Alexandro, if you don't mind, since you have a very clear screen and clear microphone. So I may call on you again.
Okay.
So don't you dare go away. But I'm going to go back to the lecture.
Right.
Thank you.
Welcome. How do I?
I just take over automatically.
Oh, okay.
There's a little square at the inside the circle where it says stop sharing.
Oh, I saw it. I didn't know I could press it. Okay.
No, just in case. But I'm taking over, so unfortunately for you, you know, I can do that, right? Yes, I know, right? So obviously, this is going to be one of the most confusing, but the most important step in dealing with arrays. And the reason is that when I want to perform operations, I know how to perform operations. I know why I need to perform operations, right? But I need to know for sure that I'm extracting the data that I need. And that is very important. Whether you create bigger arrays, but most importantly, most applications, you extract a bunch of numbers from a given array, and you need to deal with them for whatever reason. So this is something you should become good at. You should pay attention to. You should practice often, because if you can't extract the data, who cares about what you're going to do with it? Even if you know, because you don't have the data. You need the data to work with, right? More examples here. For example, it says from the second to the third and from the first to the third. So in this case, from the first to the third, that means first, second, and third, right? Because the increment by default is 1 when it's missing. This colon means is like a pattern, right? It's not the same thing as the colon by itself, which means every. In this case, it means from the first to the third. Before, when I needed, no, I didn't show it, not yet. Oh, here it is, right? This is the second example. When I wanted only the first and the third, I had to put them between brackets. Of course, in this case, I could have been, obnoxious, and I would have said, what's another way of putting 1 and 3? What can you think of something else that also gives me the same thing? What other ways would you write it that will signify exactly this, 1 and 3? What do you guys suggest? Write it as a pattern. And how do I write it as a pattern? Something, colon, something, colon, something. No, the last one I want the first and the third column, not the second and the third, right? First and the third. So rewrite what you did. Not exactly, because this gives me the first, the second, and the third. I want the first and the third. How would you write it? Keep trying again. What is missing there? I don't want the second column. So how do I get rid of it? 1 colon what? No, here you're saying the first row and a third column, right? I mean, that column should not exist there, so I don't know why you have it. But it means the first and the third. So how do I skip the second column? No, because first of all, the semicolon should not exist, right? But if you put a colon, it means every column, right? If you put the colon, it means every column. So the 2 and 3, 2 column 3 should stay there, right? But it's the 1 and 3 that I want to see as a pattern, something like this, but not exactly, because here it means first, second, and third. How about this? Does it mean the first and the third? Check your chat. Because which columns are addressed here? It's first, then plus 2, that's 3. That's it. So you can write it that way, or you can write it in between brackets. Of course, if you have only 2, you can do it either way. But if you have 5 or 6 numbers, Oh yeah, the increment, right? Yes, the increment is 2 now. That's how I skip the second column, right? Because from the first, I go to the third directly, right? Because 1 plus 2 is 3. So either way you write it is fine, right? But when you have a bunch of numbers, let's say 5 or 10 of them without any pattern, then the brackets should be necessary, should be useful, rather than trying to figure out an increment that would do the job, right? Okay. Okay, again, here it means from the second to the third and the first and the third column. So second to the third, as far as the rows, and the first column and the third column. So it's 4, 7, 6, 9. 4, 7, 6, 9. Agreed? Now, sometimes, if I just talk about two-dimensional space, square root of x squared plus y squared, if x and y are the coordinates of a point, it's like the length of the vector, or the hypotenuse, if you will, of a rectangle triangle, right? But then if you have n-dimensional space, if you have a point with n coordinates, w, x, y, z, whatever, right? Some space. Then the length, it's called the geometric length of x, is the square root of x1 squared plus x2 squared plus all the way to xn squared. That means you take x, whatever the number of points, and the number of points in it are x1, x2, x3, and also until the end. If you want the length of that vector, not just the length, physical length, because we don't know what n-dimensional space looks like, right? So, but that's called the geometric length. If you can use the square root of. And so I lied a little bit before because I said we would never see matrices again. But in matrix operations, if you multiply x, which is a vector made of x1, x2, x3, like just numbers, 1, 2, 3, 4, 5, for example, right? Then by taking the product of x and the transpose of x, it's exactly this one that you're evaluating. Of course, this one, that means the x1 squared plus x2 squared plus xn squared. And then when you put square root, it's the square root of the whole thing. So x times x squared, it's exactly the inside of the radical, right? It's x1 squared plus x2 squared all the way to plus xn squared. So instead of writing this entire expression, you just write this. But if it's a column vector, then you have to write it this way. So this is just an example of how matrix operations have to abide by the rules. Because if you write it this way, if x is a column vector, it's not going to work. It's going to be not accepted by MATLAB, because this is not a valid matrix operation. The size of the arrays that you operate on has to verify or abide by some rules. But the good thing is that it's a very simple. Imagine if x is an array with 100 numbers, I don't want to write x1 squared all the way to x100 squared, right? So this simple writing makes it possible to evaluate this entire expression. Even if it has 100 elements, 1,000 elements, it doesn't matter, right? Also, before that, that's also another one, at least when we talk about row or column vector. Imagine, for example, if I have quiz 1, and I don't know how many students I have, so I can count them, or I can ask MATLAB, give me the length of x, give me the length of that vector. And it's going to tell me, let's say I have 20 students, right? Because if I have 20 elements of x, that means 20 students. So it's going to tell me 20. Of course, later on, we're going to see when we deal with two-dimensional arrays, it's not that simple. But when you deal with a row vector or column vector, it tells you this length function, tells you how many elements make up that vector. So like in this case, it's an n element vector, right? There are n points, n values in that vector. Now for the absolute value of x, right? And we used ABS before when we dealt with complex numbers to find the magnitude of a complex number, right? But what it leads to when we deal with the real vector or vector with real values, it just takes the absolute value of every point of x1, x2, x3. That means if it's positive, it remains that way. If it's negative, it becomes a positive number. That's what absolute value of x would lead to. As an example, for example, if x is a row vector, right? It's a row vector. Y equal x prime, that becomes a column vector. Remember, this time is a transpose I'm looking at. Length of x, that's 3, because there are 3 elements. Length of y is 3, because it has 3 elements. So as you see here, row vector or column vector, it doesn't matter. You can use the same function, and it tells you exactly how many elements make up those vectors. When you deal with square root of x and x prime, it means square root of 1 square plus negative 2 square plus 3 square. That's what it means, right? X times x prime for the row vector. Remember, this operation works only if you have a row vector. And if you deal with this one here, this column vector, I told you have to reverse the transpose, so the y prime first times y. And of course, it gives you the same number because square root of 1 squared plus negative 2 squared plus 3 squared, that's the same as this one, right? And the absolute value of x, you see here, the positive numbers remain positive, and the negative number becomes a positive number. And the same thing applied also to the column vector. Okay. That you can look at it yourselves. Obviously, in this case, we already dealt with them before, right? With complex numbers. We said the absolute value, that's the magnitude of the vector, of the complex number, whatever that number is. If you deal with the conjugate, that's if it's a plus ib, it becomes a minus ib, that's all. So those are just reminders. And the reminder that the square root of x times x prime, that's the same thing as the absolute value of x directly applied to x. So you write it this way, or you write it this way, that's the same thing, right? So the magnitude here would be that kind of like geometric length, right? So in this case, well, sorry, in this case, it's the length of the vector, right? Whereas here, it's the absolute value of complex numbers, right? The absolute value of x. That means the absolute value, the magnitude of every element, right? Like in this case, square root of 1 squared plus 1 squared, that's this. Square root of 2 squared plus 2 squared, that's this. Square root of 3 squared plus 3 squared is this. So the absolute value just means the magnitude of every complex number in the vector x. Whereas the square root of x times x prime is the length of the vector, right? That means you take the x as a vector, in this case, it's three-dimensional space, but the numbers are complex, and it's this operation that takes place, right? And this is leading to this number, which of course is a real number because if you look at the operation, it involves the magnitude of each term. So this is the geometric length. So this is the operation. So here you take the magnitude of the first number squared, magnitude of the second number square it, third number square it, add them up, and take the square root. That's what this operation would lead to. Whereas the absolute value just means give me the magnitude of each number separately, right? They're independent from each other. Now, functions that exist in MATLAB, which you may find useful in the near future, and that means this semester. One is, I am asking for 3 outputs. I'm asking for 3 outputs, UVW, because the format for the function, it says, I can give you up to 3 outputs. And what is the function? Find x. First of all, I need to know, right? When I go to the function, to a help file or whatever, it will tell me you can have up to 3 outputs involved. I don't know what those outputs are yet, but that's what I have available. Then I need to know what this find means for an array x. Here it says for a 2-dimensional array, or 2-dimensional array, give me the row and column indices. Indices, that means row m, column n, right? That's the index, the location of the row and the column of the non-zero elements of x. That means if there are zeros in the array, skip them. If there are zeros, skip them. But if there are non-zeros, I want to know which row and which column those numbers are located. However, we have to figure out how this is implemented, because as I told you before, we're going to encounter a lot of functions that are performed on arrays. And in many cases, you will see that it will operate on each column at a time, independently. Maybe not this time, but some other functions later, it will be perform the operation on the first column, give me a number. Then go to the second column, perform the operation, give me a number, and so on, right? But in this case, we will see through an example what it leads to. And maybe this time, instead of me talking about how this is the way it happens, you tell me based on the result what that operation does, right? I give you again the length function, which we had seen very simply for row vector and column vector. But this time, right, this time I'm looking at 2-dimensional array. It's still going to give me one number only. Later on, we're going to see a function that gives me more than just one number. But here, the length gives me only one number. So it's going to look at the number of rows, and it's going to look at the number of columns. If the number of rows is greater than the number of columns, it's going to give me that number, the number of rows. If the number of columns is greater than the number of rows, it's going to give me the number of columns. Of course, you don't know. If it says, if it's a 3 rows, 5 columns, it's going to say 5. If it's 5 rows and 3 columns, it's going to say 5, because it's the larger of the two, right? So in this case, you will not know. You just know what is the largest number involved. Is it rows? Is it columns? You don't know if it's rows or columns, but at least I know which one is larger. That's all I care about. And in some applications, it is important to know which is the larger one. 3 rows, 5 columns, maybe then I can put 2 more rows and have 5 by 5, for example. If I have 5 rows and 3 columns, I can add 2 columns and make it 5 by 5, for example. But that's how the length works for 2-dimensional array. It's going to give you a single number. It's the larger of the two, whether it's rows or columns. So you look at the rows, you look at the columns, whichever is larger, that's the number that it will display. Now, as an example of functions that deal with columns only, for example, maximum is one of them. So it's going to look at a 2-dimensional array. It's going to look at the first column and tell me which one is maximum, which one is largest, and it's going to print it. Then it's going to go to the second column, looks at the maximum value in that column, and then it's going to print it, and so on. So at the end, you end up with a bunch of numbers, which is really a row vector, where each number is the maximum of a specific column. And the same thing with minimum. It's going to look at every column and gives me the minimum for each column and puts them all together as a row vector. Before I look at the more functions, let me just say what it looks like for at least these functions. For example, I created an array with 3 rows and 5 columns, right? You see here 3 elements. 5 elements. That's the first row. Then semicolon, second row. Then semicolon, third row, right? So 3 rows, 5 columns. When I used UVW, find X, it has shown me that U is 1, 2, 3, 1, 2, 2, 3, 1, and so on. V, the same idea, and W, the same thing. 3 separate matrix arrays, 3 separate arrays. Here I've artificially put them together. You see here that U, V, W, it's not the same thing as this. Even though I wrote it this way, MATLAB gives me 3 different arrays independent of each other, separately. But then I put them together myself. I type in this and push enter. And if you remember, when you put them in between brackets with commas in between, you concatenate them, you combine them horizontally. So I took this one, then took this one, put it next to it, put this one next to it, and you get now, let's see here, very strange, 4, 6, 8, 10, 11. Yeah, let's I think, oh yeah, sorry, what am I looking at? I don't care about the number of rows and columns, because this is about, this has 11 elements, this has 11 elements, this has 11 elements. So when I put them horizontally, this is what I get. However, what do these numbers represent? So that means it's going to go, it deals with the entire array. It looks at the entire array, but it looks at it from one column to the next column to the next column and so on. So it's going to look at the first column, and the first element of the column is a 2. That's non-zero. So it tells me value 2 is on the first row and first column. -8, that's a non-zero. So -8 is the second row, first column. 5 is on the third row, first column. Then it goes to here, right? And remember, 1 column, then 1 column, then 1 column, so on. -5, that's the first row, second column. 4, that's the second row, second column. 0, it will skip it. Because I said before, it only cares about the non-zero values. 0, I'm going to skip it. Then the next number is -6. That's why it appears here right now. So every 0 is skipped, and there are 4 zeros that are skipped. So out of 15, that's why we're left with only 11 pieces of data. So in this case, -6 is on the second row, third column. -6 is on the second row, third column. So there may be situations where you want non-zero values. Maybe 0 means the product is defective. And if the product is not defective, then there's a number associated with the cost or with profit or whatever it is, right? And so 0 value, you don't care about, right? Because they're defective, you cannot sell them. And so when you pick up the other non-zero values, that means now maybe those I can sell. And it tells you exactly from which machine and which element. So maybe row and column means, you know, which machine and which element, right? First machine, first element, second, third element, and so on. Second machine, there would be second row, first element, second element. So that means the first bar, second bar, third bar that you worked on, right? So every time it does not satisfy the characteristics, you put a 0. And if it satisfies the characteristics, then you put maybe how much you can charge for it, whatever, right? For example, I'm just stating examples like that, right? So this could be a useful information from that point of view. And before we go to examples, let's see more functions. See, before when I dealt with max and min, I only asked for one output. So by default, when I don't use more than that, you see here, I asked specifically for UVW. If I just put two names, U and V, it doesn't have to be U and V. I could put A and B, right? It's going to give me the indices only. If you remember the example, U and V, it will not give me this. If I put just a single name, it will give me this, but not this and not this, right, in that order. So the idea here is that if I put the three of them, then you get all the three arrays. And of course, for max and min, because I said A equal, that means it's only one name, then it's going to give me just a maximum. However, if I put two names, and the way that function was created, max, it can have, let's say, up to two names, right? What is the purpose of the two names? The first one is the maximum values. Yes. Because remember, max means give me the maximum of each column, right? But the second number, it says where that maximum is. For example, if I go to quiz 1, I want the highest grade. I use maximum. But then I would need to know which student has that maximum grade. So if I put A and K, now K will represent the number related to that student. That means it's the third element in that column, right? It means the third student that has the highest grade. So if I put only one name, I only get the maximum values. If I put only one name, I only get the minimum values. If I put two names, not only do I get the maximum or the minimum, but I also get the location of where that maximum or minimum is, right? Before, when we talked about length, we talked about row vector, column vector. We said, okay, row vector, column vector is the number of elements in that vector. But when you're dealing with two-dimensional arrays, then we said the length can only give you one number. It looks at the number of rows, it looks at the number of columns, and whichever is larger, that's the number you get. It does not tell you if it's rows or columns. It just tells you 5, meaning it's either 5 rows and less columns, or 5 columns and maybe less rows. So 5 would be the answer. But if I needed to know specifically how many rows, how many columns, then you use the size function. Size will give you two numbers. One is the number of rows, and the second one is the number of columns. Sorting, again, it's an operation on each column, just like max and min. And what it will do, it takes the first column, and it will redistribute the number, reorder the number, the sequence, by having the smallest at the top, at the beginning, then the next, all the way to the end, which is the largest. So that's what sorting is, right, for numbers, right? 0, 2, 15, 75. So it's from low to high, right, in ascending order. And of course, there will be, it's the same, it's an array with the same number of rows and columns, but it's just that each column now is ordered from low values to high values. That's what sorting does, right? Of course, you can do it also alphabetically, by the way, because from the view, capital A is 41 hex, and capital D is some other numbers, which is 41 plus 3, right? Yes, 44 hex, right? And obviously, by sorting it, it just looks at the ASCII code, and whichever has the smallest ASCII code, that's the one that will appear first. So you can do sorting of characters by stating that it's a string of characters, and MATLAB will use the ASCII code, and we'll use this sorting to decide which word should come first, right? And of course, the idea is the program is also written in a more sophisticated way, in the sense that if I have names, it's going to look at the first character. But if your name and my name start with the first character, then it's going to move on to the second character, and so on, until it finds out which one comes first. The sum is another operation that is executed on each column separately. It's going to look at the first column, add the numbers up, and print the result. Then goes to the second column, add the numbers up, and then prints the result. And so you will have a bunch of numbers. Each one is the sum of the elements of a given column. So now going back to the examples. So in this case, if you look at the array X that we started with, maximum, well, the largest value here is 5. The largest value here is 4. The largest value here is 0. The largest 9. And the largest is 4. So that's your maximum. And the minimum, of course, is the minimum for each column, right? However, if you remember, I said if you ask for two numbers, like in this case, I didn't say A equal max X. I said AK equal max X. Of course, because I didn't say A equal, that's why MATLAB by default says A and S equal, right? It chooses for me. But here, I'm giving them names. So A is still the same, 54094, right? That's the maximum for each column. But K is the location of where that maximum is. For example, 5 is the third element of this column. 4, which is the maximum, is the second element. That's why you see it 2. 0 is the first element. 9 is the third element. And 4 is the first element. And of course, that's true for the minimum. Now, do you get this one? Do you see it in your head, right? Not only you get the maximum or minimum, but you also get the location. So if I had given, let's say, 5 quizzes, then on the first quiz, it tells me, here's the maximum, the highest grade, and here's the student that has the highest grade. Then it's going to look at the quiz 2, here's the highest grade, and here's the student that has the highest grade, and so on. That's what AK equal would lead to in some applications. Anybody with questions? I am so lost, you know. All right, obviously, either you're mesmerized, so much to absorb, but of course, every time you see something for the first time, expect that to happen. Second, as we practice, it becomes like, just like what you learned 3 weeks ago and you thought it was hard, and now you say a big deal, right? That's the same thing that's going to happen with every topic, everything in your life for the next 50, 60 years, right? Every time you start something new, you're going to be frustrated and lost. And every time you master it, you say big deal. Oh, thank God, because then you say, okay, let's move on to the next topic. Otherwise, you'll be stuck with the first forever. So, in this case, another example. Oh, yeah, sorry, man, because I didn't discuss the other function. You see here, let me ask you first, because it's not here showing, right? What would be the length of this array? Please tell me in the chat. What would be the length of this array? If you remember what length stands for, right? Go ahead, make my day. What would be the length? Do you remember what the length means? The function length. Well, you don't say length 5, you say length x, and the answer would be 5. Why do you think the answer should be 5? Why is it 5, Nicholas? No, it doesn't have 5 rows, right? What does it have? 3 rows and 5 columns. Yeah, but instead of saying the number of elements in a row, what you say is that it has 3 rows, 5 columns. Which one is larger, 3 or 5? 5. Then that's the length. I don't care if rows are larger than columns or columns are larger than rows, right? I say which one is larger, and that's the number that MATLAB would give you. Agreed? So yes, the amount of numbers in one row, yes, but that's the same thing as saying number of columns, right? So we prefer to think of it that way. How many rows, how many columns? 3 rows, 5 columns. 5 is larger, so 5 is the answer. Okay? Thank you, Nicholas. However, when you look at the size, it gives you specifically 3 rows, 5 columns. The first number is for the rows, and the second number for the columns. Sometimes I don't care about rows or columns. I just care about which one is larger. There will be applications where I need to know which one is larger. Not smaller, but larger, right? That means I have more space to complete it to make it called a square matrix. A square matrix is like it has as many rows as columns, right? Sorting, you see here, -8, then 2, then 5. That's how you sort it, right? Here it's -5, then 0, then 4, right? So from smallest to largest for the sorting. Sum, it will add these numbers, 2 plus 5 minus 8. 2 plus 5, that's 7, minus 8, that's -1. -5 plus 4, that's -1. -6, then -3, that's -9. 7 plus 9, that's 16. 4 plus 3, that's 7. So it adds each column separately, right? And then if I want the sum of all the elements, I say, what's the sum of all these? Now, I know that each number is the sum of the columns, and by adding them up, that means the same thing as adding all these numbers, all of them. And of course, in this case, how else could I write this line, sum of answer? What's another way of doing it so I don't have to come up with intermediate results? How would I get this number with one single line? Instead of this and this, a single line to obtain this. Somehow figure out how to combine this and this, right? How? Tell me, tell me, tell me. Check it out. Suggest. Dare tell me. Yes! Oh, my goodness. You're going to give me a heart attack with your brilliance, you know. I'm proud of you guys. Again, I don't care if you got it right or not, but every one of you is participating. I love that. I love that. Yes, yes, yes. I think this is a good day for me. That's for sure. No, don't believe in jinx. Come on, you're an engineer. That doesn't exist. I don't care. The only thing that is you have to be afraid of is that if you brag next to people who are inferior to you in skills, and or you make them look bad in a conference, right? By being brilliant and they're you know, and whatever, right? Then what happens is that they may become your enemy. They may become an adversary, try to hurt you. That's different from a jinx. A jinx is like somebody says, well, yeah, some kind of like force that will make me suffer for. No, no, no. If there's any suffering, it's because somebody's envious of you and tries to hurt you. So you try not to brag, not to be arrogant. But then if somebody is inferior to you, too bad, man. If I have to say a result, I'd say it. But I will try to say it in a way that does not affect other people. If I can, then the hell with them. That's their problem. But that means you have to watch your back. That's all. There is nothing like jinx. It doesn't exist, you know. So jinx does not exist. You're still an engineer, and you have to grow up as an engineer. You cannot believe, like, you know, a black cat passes by. Who cares? Oh, going under a ladder. Yeah, people think it's bad luck, right? The hell with that. The only bad luck that occurs is like if somebody drops a pot of paint on your head while you're crossing. That's not jinx. That's that's an accident, right? But otherwise, that doesn't exist. People are afraid of the number 13. The hell with that. It's just a number, man. So you cannot advance when you have all these limitations, which are not based on anything practical. And engineers have to be practical, man. There's no subjective. Of course, we have theories about, you know, about life, about phenomena in life or whatever. Those are theories. They're not just like something from somebody decided maybe 500 years ago and everybody followed. No, no, no. You show me, man. Tell me. Prove to me. That's it. If I use the number 13 and I don't get hurt, does that mean the jinx didn't work on me? And you, out of 10,000 you do things you do, once you get into problem, that's probably because of that jinx. What about the other times? You did things and nothing happened. Therefore, David, be an engineer, and an engineer, of course you're not, you know, right now you're not a child, by the way. I'm sorry to say, you know, you're an adult. If you make any mistakes, you would pay for it. So, of course, the things we grew up with, I agree with you, you know, it's hard to get rid of. I agree, right? No matter what you do, it will be there. But at the same time, you have to make your own rules. The only rules that you have to abide by are rules of dignity, professionalism, things of that nature. And as I said, wisdom, right? Like if my friend and I like my friend, I'm not going to say things that will make him feel bad because he doesn't get it and I push through and he feels even worse. If I love him, I will try to say it in a more simplistic way. Right? So you just have to be wise. That's all. You don't brag in front of, you know, the boss that you did all the work, and the other guy says, okay, well, maybe give me some credit, a little bit, you know, so I can be grateful. Otherwise, they become upset, and who knows what they will do to you, right? Sabotage you or something. So it's about wisdom, not jinx. It's about wisdom. In the meantime, I think it's about time we look at some examples so that we learn more. So the only way to do it is to do it through examples. So let me see what example I can think of, or problems that we work on to solidify, to consolidate all that information, right? So in this case, okay. Okay, so let me see here. I don't think I want to do any of these examples. That you can do yourselves, right? I mean, anytime you want to. So I prefer to deal with problems, right? Not just, I don't want to deal with matrix operations, right? We dealt with them in one case, at least in two examples. I want to deal with arrays, right? But for that, I have to teach you one more thing, right? Maybe I will ask you to think about them, and then add the one single thing that is missing in all this, and that's the kind of operation I talked about before, which is element by element. So if it's not a matrix operation, it's what we are interested in is element by element operation. So we have seen some functions. If you use the functions, you don't care about this element by element, right? The functions will take care of things. It was programmed to know what to do when you deal with the arrays, right? But if you have to use them in some cases, that element by element has to be explicit, and we will see how. But in the meantime, let's see here. I'm going to just write it in the chat. That way it's clear. And in the chat, I put definitely. This is from the 3rd edition, but then I will show you the 4th edition. So it will be 14, right? And then what? Definitely 16. Then what? Well, 18 I'm not going to do because it's very similar to 14. 19 for sure. Okay, that would be, I think, a major amount of work. Let's stick with these 3 problems. So, as I said, first, look at them, study them, try to figure out in your head what you would do, right? And then I will go back and I will teach you this element by element and what to do about them. It's just a 10-minute job, and understand why this element by element operation is useful, right? Any questions? We're going to take a break and then we could talk some more. And of course, I want Alexandro to be back later, right, to show us his screen so that we can do the work from his point of view and your point of view, right? I know. So let's take a break first, and then when we resume, I'm going to need you, Alexandro. Is that okay? Good. Very good. So let's take a break. Unless, of course, you have a question right now before we move on. So, oh, sorry. Let me find the 4th edition. Where is it? Where are you, 4th edition? Where did I put it? Mamma mia. Okay, 4th edition. I don't know where I put you. 4th edition. Oh, here it is. Okay. All right. So chapter 2. Oh, sorry. Let me first enter this, and then from the 4th edition, it would be. Okay. I think. Okay. Let me just type it. So 4th edition. So it will be 23. Then 25. Then the other one was about the alloy, not the alloys, the material. Yes, and that would be 28. So for the 4th edition, the problems are these numbers, and for the 1st edition is 14, 16, 19. So if you don't have any questions, we'll meet soon.